do something to them, but so that by the time they're 15-year-olds, they're performing well below the international average. And it's by no means homogeneous in the United States. If you look at the scores for 15-year-olds, you'll see that it varies greatly by states. Here are various U.S. states compared to the to various countries, and you'll see that Mississippi is slightly above Egypt. Massachusetts, which scores higher, is nevertheless well below, in fact, Japan, South Korea, and Singapore. So no American state can compete with those countries in Asia in terms of education of science for middle school students. Now, it gets worse as people grow up. And every year, the National Science Foundation does a study of scientific literacy. And I collect them and look at them periodically. Here are some recent ones. It's a 2001 study. It's more recent. A new one just appeared, in fact, but I thought I'd use this one because it has something I want to say. So in the study, 53% of American adults were unaware that the last dinosaur died before the first human arose. That may not be so surprising. The next one is the one that always surprises me. 50% of American adults knew that the Earth orbits the sun and takes a year to do it. Now, when I saw that, I thought it was a trick question. So I went to the study. The study said, the Earth orbits the sun and takes a year to do it, true or false? Okay. And absolutely every year that it's been performed, half of the American public get that wrong. I could make a political statement, but I'm not going to. It was, however, a landmark year in 2001 because it was the first year that more than 50% of American adults claimed to know that human beings, as we know them today, developed from earlier species of animals. That was the first time more than 50% of American adults had agreed with that statement. It didn't last long, and if you've read any recent surveys, here's a recent one, for example. 60% of U.S. adults surveyed in April 2007 stated their belief that God created humans in their present form less than 10,000 years ago. 60% of American adults, in spite of the fact that that is false. It's not arguable. There's no debate. It's nonsense. Okay? Now, this scientific ignorance is unfortunately, in my experience, compounded by journalists, many of whom are quite uncomfortable on matters of science. I interact with a lot of journalists. I have great respect for journalists. It's a difficult task. But it is rather surprising to see the hesitancy that journalists will use when discussing matters of science as compared to history or economics, where they might ask probing questions or disagree with the speaker. But in matters of science, there's great hesitancy. And I again, can relay interesting stories of interviews with anchors about various issues that I won't, but I'll be happy to talk about in the question period if you want. In fact, many journalists have told me that if it had not been for a physics class at some point, they would have done something else. So that they're very uncomfortable, and that journalism itself, in fact, I would argue, has an inherent tension built into it that makes it very difficult to cover science. And that's because journalists are really trained to look for the fact that there are always two sides to every story. And they work very hard to try and find those two sides. But what is profoundly important about science, in fact, what makes science largely unique in human intellectual endeavors, is that most times in science, one side is just wrong. And that's really important. Because if that weren't the case, if one side wasn't unambiguously wrong, we couldn't make progress. In fact, that's what science is all about. Science can never prove anything to be right. It can only prove things to be wrong. And the great thing is, once they're wrong, we throw them out. We don't have to talk about them anymore. We don't need creative thinking classes to discuss whether the Earth is flat, or to debate that issue, or whether the Earth is 6,000 years old, or any of the other things that we know to be wrong. And that is the way science makes progress. But because of the fact that journalists really always have to try and find another side to a story, most reporting does not reflect that. Because, of course, you can find a PhD to say absolutely anything you want. And so if you are looking at any issue and reporting on any issue, you can always find someone to disagree with it. And then if you quote one person on one side and one person on the other, it gives the impression, of course, that there's a controversy. And I'll talk about artificial controversies that have existed in this country on various issues. when really, in fact, there's no controversy at all. Now, on top of education, we have this problem. I was, as you heard, chair of the physics department at Case Western Reserve for many years. I got this video catalog, and it's the kind of thing that is sent to many high school science teachers and middle school science teachers to help make their classes interesting. A lot of middle school science teachers need that because in this country, approximately 90% of middle school science teachers have never taken a science course beyond high school. Okay? They're the ones who are teaching our children. And so they need props. And this is, I'm all in favor of things that make science interesting. But the interesting thing is when I got this catalog, and this is really for me, I don't think you'll be able to read it, but I'll read it out to you. This is page 71, said Mysteries of Science. And in the center there is a National Geographic video, Mysteries of Mankind. So it seems like a reasonable set of videos to show the class. Let's look what the other videos are. Bermuda Triangle. Bermuda Triangle, Secrets Revealed. Nostradamus. One could go on. My favorite two in the end, there's Loch Ness Monster. And the last one, of course, Loch Ness Discovered. And so the point is, if you don't have a filter, if you're a middle school science teacher and you don't have a filter, and this seems reasonable, then so do these. And so the nonsense continues at all stages that people are barraged with. And that is a huge problem, because if people don't have the filter to distinguish sense from nonsense in science, that, as I will argue, is in fact a huge problem for our democracy. Oh, I guess I'll go back there. Okay. In fact, I'll argue about it now. I'm a scientist, so I care about these things. But why should we care if we screw up the science? Okay? I would argue that it is vitally important that we not screw up the science, because once we blur the truth in one domain, one important domain of public discourse, once we allow nonsense to stand with impunity in one key area of human activity, I believe we've jeopardized the very basis of a healthy democracy. In particular, now more than ever, because scientific issues form the basis, I would argue, of almost every important political decision that's going to be made in the next decade. Now, science, I think, is relevant for democracy in another sense. This is a quote from one of my favorite physicists, Richard Feynman. Some of you may have heard of him. And I'll read it to you. The only way to have real success in science is to describe the evidence very carefully, without regard to the way you feel it should be. If you have a theory, you must try and explain what's good about it and what's bad about it equally. In science, you learn a kind of sort of standard integrity and honesty, whether you want to or not. And the idea of not cherry-picking data, the idea of looking at things that disagree with your a priori ideas, is incredibly important, and I would argue incredibly rare in many places, including this city. The ethos of science, I would argue, depends on honesty, as I just said, creativity, open-mindedness in a way that I'll describe momentarily, full disclosure, reporting all of the data, and my favorite, which is anti-authoritarianism. There are no scientific authorities. There's no such thing. There are scientific experts. But there's no one whose word is not subject to questioning by the lowliest, you pick it, graduate student, whatever you want. And that is incredibly important in science, that anyone can question, and everyone should continue to question. Now, these issues have become particularly important in the last decade or so as science has become increasingly politicized. I have a quote here, actually, from George H.W. Bush to the National Academy of Sciences in 1990. And he said, "Science, like any field of endeavor, relies on freedom of inquiry. And one of the hallmarks of that freedom is objectivity. Now more than ever, on issues ranging from climate change to AIDS research to genetic engineering to food additives, government relies on the impartial perspective of science for guidance." That, I believe, is a perfect statement of what the relationship between science and government should be. That has changed somewhat in the intervening 17 years. Here was a statement, for example, by the press secretary of our current president, who says, "This administration looks at the facts and reviews the best available science based on what's right for the American people." Do you detect the slight difference? You decide what's right, you pick the science that's based on that, and that's what you use. And that's exactly the kind of cherry picking that science is supposed to be not about at all. And I want to talk about my concerns about that in a variety of areas.